Alright nerds, so let's look at some basic types of equations. These aren't the standard reactions we'll look at, but these are the formats for certain equations. So by the end of this, you should be able to identify certain reactions and use the terminology, the nomenclature of what they are. This is your vocab. I just need you to pause the video, write this down, you can have it to refer back to as the lesson moves along. So the first one we want to look at is a synthesis reaction. So this is essentially, we've got A plus B. These are our reactants. They're on the left-hand side. And they go together to form a molecule or a compound, because it could be ionic, of AB. An example of this is when we've got hydrogen and oxygen mixing together, and we get water. Now, of course, we need to balance this reaction. There we go. So we've got two waters and two hydrogens. Now we've got four hydrogens over here, four hydrogens there, two oxygens, two oxygens. Nice. Balanced equations. The opposite of a synthesis reaction is a decomposition reaction. This is where we start with an AB, compound, molecule, whatever, could be ionic compound, and it splits into AB, so A plus B. An example of this is water, so the reverse reaction. Now, if we've got water, because it's a chemical change, it requires energy to reverse it. So this is what this symbol here means. That means electrical energy. So we've got water as a liquid, and it splits into hydrogen gas and oxygen gas. And of course we need to balance it, so we've got two waters, two hydrogens, and it all matches up. This reaction down here is wrong. That should be that, and that should be a plus. Alright. Displacement reactions. So there's two types. There's the single, there's more than that, but we'll stick to two. There's the single displacement. This is where we have AB plus C. And see that AB is a compound or a molecule together, and C is separate on its own. And it goes to AC plus B. And what's actually happened is that the element C has displaced this B. So that's why it's called displacement. This is a single displacement. An example of this is when we add magnesium to hydrochloric acid, right? So if we add magnesium to hydrochloric acid, what we end up with is magnesium chloride plus hydrogen gas. And of course we need to balance it. So the next is the double displacement reaction, which is where we've got AB plus CD. And we can see that the second species in each compound there swaps over, it displaces. So that goes to there, that one goes to there, and we've now got AD plus CB on the other side. A good example is sodium sulfide. Sodium sulfide plus calcium chloride. And this gives us calcium sulfide plus 2 sodium chlorides. And that's a balanced reaction, and that's a double displacement reaction. You can see that the ions there, the negative ions, have just swapped over places. Then we've got combustion reactions. Now, combustion reactions are where we set things on fire, or we explode them. Or, to be honest, when we oxidize them with oxygen, like rust, at a really low rate. That's still a combustion reaction, it's just at a slow speed. So what happens is we get all of the different species on the left-hand side, essentially combined with oxygen on the right-hand side. So the energy there is splits. So whatever it is we're burning, whatever the fuel is, it splits into its different atoms, and then oxygen combines to all of those in whatever ratios it will. That's why you've got a little X there. Two examples here. One is methane. We see methane is made of carbon and hydrogen. On the other side we have carbon dioxide and water. That's what happens when we combine those with oxygen. Then we have magnesium. If we burn magnesium, we end up with magnesium oxide. So you can see the species on this side here are bonded with oxygen on the other side. Our last one is the precipitation reaction. Precipitation reaction is when a solid will come out of mixed aqueous solutions. So you have a solution and another solution, you mix them together, and a solid forms out of those ionic compounds. So, for example, AB, aqueous. Now here the states of matter really are important. Aqueous plus CD, aqueous, gives us AD solid plus CB aqueous. Now this depends on the solubility rules, and you can always look those up in a little table. So therefore, this is a type of displacement reaction. We can see that here, right? The B's and the D's have just swapped places. It's just that AD, when it's together, is insoluble. It makes a solid. So a good example of this is silver nitrate plus sodium chloride gives us silver chloride, which is a solid, plus sodium nitrate. Now here's the interesting thing, right? We could write this down like this. Ag. So if you wanted to do ionic equations, now we've got these, right? What is actually really interesting here is that that and that are the same on both sides. So if we were to talk about this as an ionic equation, the only ions which are actually involved in the reaction are silver and chlorine. And they're the only ones who change from side to side. Otherwise, the sodium and the nitrate, they actually stay doing exactly what they were doing before. I hope that made sense. It's a nice, quick little reference. If you have any questions, put them in the comments below, and we'll get back to you as quick as we can. Thank you for watching. Hit subscribe so you can keep up with everything we're doing. And yeah, we'll see you next time. Bye now.